Alright, so we're looking at related rates of change. So we're going to actually start off with this example. So a square has a side length L. So when L equals 10 meters, the side length is increasing at a rate of 5 meters per second. What we want to know is what is the rate of change of the area. So what could be happening is that we have a square, and it has side length L. Now, what's happening is that the square is growing, okay? So it could be growing at a quicker rate or a slower rate. The rate of change at which these lengths are growing can be changing as time changes. But what we know is that at the moment that L equals 10, what we know, when L is equal to 10, we know that at that exact moment in time, the side length is increasing at a rate of 5 meters per second. So what we can do is that we can kind of think of the length as a function of time. Okay? So how do we think of this rate of change of the length? Well, remember that the derivative L prime of t, that's the change in length over the change in time. This right here is going to be a huge deal for the entire section. Is that we're going to be thinking of the derivative as the change in one object with respect to the change in time. We can also write this shorthand. We can just write L prime of t. So how do we figure out what the rate of change of the area is as the length is changing? Well, another question is, how do we relate the length of a square to its area? Well, we know that area of a square is going to be whatever length the side is squared. So what we're going to do is that we're going to take the derivative of this. Now, before we take the derivative, if the length is changing in respect with time, wouldn't the area also change with respect to time? That is, can't we think of the area itself as a function of time? Like so. So now if we want to do the rate of change, whenever you see this word, always think we're going to have to take the derivative. So take derivative. Oops, take the derivative. Alright, so if we take the derivative of this side, well, the derivative of a, that's just going to be a prime of t. Okay? Now, when we take the derivative of this side, we're going to have to use the chain rule. So my outside function is squared, and my inside function is L of t. So this is going to be 2, don't forget, leave the inside alone, L of t, times the derivative of the inside. Well, the derivative of the inside is just L prime of t. Now, when we're solving for a prime of t, which is the rate of change of the area, we actually want to get a number. So we want to figure out, well, what can we plug into here? Well, they told us that L equals 10 meters, and they also told us that its rate of change is 5 meters per second. That means that L prime is 5 meters per second. So I know that a prime of t then is going to equal 2 times, well, L of t, that's L, that's going to be 10, times, and I know L prime of t, well, that was 5. Something that we need to include in these is the units. So remember, this is 10 meters, and this is 5 meters per second. So my rate of change for my area, a prime of t, is going to be, so that's 2 times 10 is 20, times 5, that's going to be 100, and that's meters times meters, so that would be meters squared per second. Another way that you could have written this, if you wanted to, is that anywhere you see an A, you could have written dA. Oops. Let's make that a different color. So you could have made that dA over dt. So all of these could have been d over dt. As well, we could have rewritten L prime of t, we could have rewritten that as dl over dt if you like. Another way you could have written this is that you also could have written it as a prime. Or you could have written this as just simply L prime. All of these are correct. So the big takeaway I want you to take from this video here is that anytime we're talking about rate of change, we are going to be talking about how our variable changes with respect to time. So it's going to be over dt. Another thing I want you to take away is that anytime I write L for the next remaining videos, or X, or whatever, you can think of this as L of t. Another way you can think of this is, remember, a prime of t, you can just write that as a prime, which you can think of as how is our area changing with respect to time. All three of these are the same, and this is the same as well. So just keep that in your bonnet while you're working on these problems.